Hello, everybody, and welcome to Late Night AWS with your host, Tommy Groshon, who is up late at night because he cannot sleep. So, he is recording videos about how the AWS Elastic Load Balancers work. So, very important thing. First is to understand the different kinds of load balancers. Amazon actually offers us three different load balancers. The classic load balancer, the application load balancer, and the network load balancer, which we can see right here. Elastic load balancing, application, network, classic. And let's talk about why each of these are different, okay? Now, of course, we have the OSI model, which is a mental model of how networks work. So, from the bottom level up, you have these different layers. Generally speaking, we care most about the bottom four and the very top one. Physical, data link, network, transport, and then up to application. Now, we call these layers 1, 2, 3, 4, 5, 6, 7, the 7 OSI layers. Now, when we're talking about the internet or the interwebs, you see, we're really talking about three main layers that are important. Those being network, transport, and application. Application and transport, you'll see over here, these are host layers because those are primarily dealt with by software. Transport is something that's primarily dealt with by your operating system. Application level, and then the higher up you go, the more it's software controlled. The lower down the layers you go, the more hardware is important. Now, at the physical layer, we're talking about how to send bits over, how to send bits over a wire, how to actually send radio waves for Wi-Fi, things like that. Data links, so we're talking about the frames. That's really how Ethernet works, and also how we interpret those wave changes. Network is we're getting into network and transport. We're talking about TCP and IP. Transport being the TCP part, transport control protocol, and network being the IP, internet protocol. These two normally work hand in hand, and it's important to remember that this is a mental model, and it doesn't directly apply to actual in the wild real life. So, now, application level. Now, normally we kind of compress these other two ones down, and like these top three are really all, these data layers are really all, we just call them the application layers. But primarily we're talking application layer, top level. In the internet, this would be your HTTP. Layer 7 is your HTTP. It's the highest level of, the most abstract thing, and your more end-usery software is dealing with that stuff. Lower down you go. IP is really handled by, your network card. IP and down, packets, frames, bits, those are really handled by your network card. Transport level, that's almost always handled by your operating system. Application level, though, from transport and up, these are all handled by a web server, a web service, things like that. Okay, now, why is this important? Because this directly speaks to the different kinds of load balancers that we have. Now, most load balancers operate either at the layer 4, which is TCP level, or at the layer 7, HTTP level. This becomes very important because which one they pick, which one a load balancer operates on, determines the features that are available, and also the speed and the latency that you're going to get your load balancing in. All right, so how does this apply to Amazon Elastic Load Balancers, you may ask? Well, good thing you asked that, because that's exactly what we're going to talk about right now. Now, historically, the classic load balancer is a layer 4 TCP type load balancer, but with layer 7 capabilities. So it's actually a very weird thing where a classic load balancer, which is the load balancer that Amazon has had, because it used to be that Amazon only had one kind of load balancer up until just a few years ago. So for the other 10, 15 years of AWS, they had one load balancer, the classic. Now, that load balancer worked in either layer 4 mode or layer 7 mode, because you could switch your load balancer when you created it. You can tell it, I want you to listen in TCP mode, or I want you to listen in HTTP mode. And what that meant, the different things that you could do is, for instance, if you were in TCP mode, the load balancer did not understand anything higher than the IP address and the port. The load balancer didn't understand anything about domain names. It didn't understand SSL certificates or anything like that, because all those things all operate at layer 7. They require layer 7 capabilities to do any of those things. Your load balancer didn't know what paths you were going to in your URL. It didn't know any of that stuff. All it knew is, I have a TCP connection I have a TCP connection that I am receiving, and then I am forwarding to another IP address and port. Okay? Because a load balancer sits in front of several other servers, and it would then connect to each of those servers at a IP address and a port, a specific port. And whenever it received a TCP connection, it would just transparently write that back to whoever it was forwarding to. Now, the nice thing about this is that you could still, operating in this TCP mode, you could still use HTTP and HTTPS traffic through there, because those all run over TCP. But, and the nice thing that goes along with that is that, for instance, SSL, when SSL request would come through your load balancer, the load balancer would not decrypt it, which is actually kind of slow to actually do the decrypt. The load balancer wouldn't do it. It would just immediately forward that on the raw TCP connection onto whatever the end server was, and that end server would do the SSL termination, or the SSL decryption and reading, stuff like that. So it was kind of nice, because at layer 4, it's very low overhead, because it's only it's just forwarding raw TCP connection bits, stream of bytes on. Okay, but you could also switch it into HTTP mode, and if you had the classic load balancer in HTTP mode, it could actually you could tell it, the load balancer, oh, here's this SSL certificate I want you to use. And then you could have HTTP traffic come to your load balancer just like before, but you could tell the load balancer to say, receive HTTPS traffic with this certificate, and then send the traffic on as HTTP traffic without the HTTPS certificate encryption. And the nice thing then was that none of your other servers needed to have that certificate and needed to know how to do SSL. Okay, so it's kind of nice. That's primarily what we tried to do, SSL termination at the load balancer. It's just a nice property to have. Problem is that while the classic load balancers worked okay at doing this layer 4 mode or layer 7 mode, they didn't, because it wasn't either one of those completely, it didn't have all of the gains that you could do by making an optimized load balancer for either layer 4 TCP only load balancing or layer 7 only load balancing. It tried to be everything to everybody, so it kind of was missing some features. It couldn't do a lot of really fancy stuff that you could do at layer 7, like, for instance, route to different servers based on what domain the request is trying to go to, or based on what is in the URL. All those things you could do with a good layer 7 load balancer. But, and then the other main thing that they were missing, and this was really just a a thing that they screwed up. It had nothing to do with layer 4 or layer 7. It was just a thing they screwed up with their original classic load balancers. Was they had built them so that they could only talk to a server on one port. They couldn't talk to two ports on the same server, and it was just a mistake they made when they built it. And an unfortunate thing was that, if you had, let's say for instance, you had two Nginx servers running on the same server on different ports, like on port 80 and on port 81, because you're crazy. And maybe both of those were serving the same thing just because you did it that way or whatever, or because you had Docker containers running and you were running the same service on different ports. That became a more common use case, but the classic load balancers couldn't do it because they were purpose-built to only, when they forwarded traffic on, it was to a server on one port, and it was like, I can't talk to any other port on that server. I don't know how. It was just too stupid. So what Amazon did brilliantly was they launched two new load balancers. They launched the application load balancer and the network load balancer. Okay, now the application load balancer is like it sounds. It's a layer 7 only load balancer. You can't take it and say, I want you to run in TCP mode. It only operates on HTTP mode, which means it is a little slower. It can handle fewer requests per second, but generally speaking, not too big of a deal. The network load balancer, on the other hand, is a layer 4 only load balancer. It is only for transport level end-to-end connections. It's only for TCP. It doesn't understand anything higher than that. So network load balancers, you can't give them, they can't do SSL termination or anything like that. Application load balancers, you could give them an SSL or a TLS certificate, and you could have them handle that and forward the unencrypted HTTP traffic to your servers. Okay, and the other thing that they added with both of these load balancers was that they both had a concept. They used this new concept of target groups, which, to spare the details, the way that they get used is you can specify many ports on a single server to route them to, and it just made the load balancer smarter. So both these load balancers have the new feature that they can route to, multiple ports on the same server, no problem. So all of a sudden, Docker containers, really any kind of containerized service wants that, now is supported. But also, the network load balancer, they were able to optimize for TCP connections, and it runs ridiculously fast. Okay, we're still talking about pricing here, but if we go over here to features, okay, when you're talking about, here we go, check this out. Network load balancers, you see here, classic load balancers, fewer things, fewer features here. Network, a little more features. Application load balancers, way more features, okay? All these extra features come at the cost of they can't handle as many raw connections, but the number is still high enough that we don't really care. A network load balancer, on the other hand, I don't see the special number that they always give, but here we go. They'll probably say it in here, but these network load balancers are optimized to be low latency, and they can handle, hundreds of thousands of connections a second. Here we go. Designed to handle traffic as it grows, can load balance millions of requests per second because it only understands that TCP layer, so it's optimized to only do that stuff crazy fast. Okay, now the application load balancer, though, check this out. Because it understands HTTP and HTTPS only, they also added in all the extra features because it's, it only does this layer 7 stuff. So it can do content-based routing. It can do things like can route to a different client based on the host field. So you could point a DNS record like app.myeducator and www.myeducator.com to both of those DNS records to the same load balancer, and then you could tell the load balancer to then send traffic for those two host names to different target groups, to different servers and ports. So, and that's something that's only possible at layer 7 because only HTTP understands what domains are. Same thing with path-based. You could say, maybe look at the URL and say, I want to route these, /admin/ whatever to this server, and I want to route /user to these other servers, So all these things possible with content-based routing. Also, they have other things like they have really good WebSocket support and sticky sessions, which are really cool, where the HTTP request that comes from a user, the load balancer forwards that on to a server on the back end, and it can remember which HTTP request from whatever client came in. It can keep routing that requests from that client in the future to the same backend server. Sticky sessions. Okay, so now application load balancers and network load balancers, super awesome, better features. Network load balancer is just a faster, better layer 4 TCP only load balancer. Application load balancer, just a better layer 7 HTTP only load balancer. And if that wasn't good enough, kids, check this out. Let's look at pricing here. Okay. Per hour that you run a classic load balancer, it's 0.025. All right, per hour. Network load balancers, 0.0225. Okay, so they're 2.5 cents cheaper. Application load balancers, the same. So you see an application load, now a network load balancer is even cheaper. The network load balancer is actually the cheapest and the fastest because they also, they have this other metric that they charge you by called LCUs, which is load balancer compute things, which are a whole ball of yarn by themselves. But classic load balancers, 0.025, 0.008, 0.0225, 0.006. Look at those. Application load balancers are the same LCU cost as a classic, but they're the cheaper load balancer hour, like the network. So it ends up that an application load balancer and a network load balancer, either one of those, which have better features, are going to be cheaper than even the classic load balancer. Amazon's doing that because they really, they would like to discontinue the classic load balancers. So wrapping up here, with Amazon, you have these 3 types of load balancers, classic, network, application. Application and network have a ton more features because they can both, the big one is they both support target groups, so they can route to multiple ports on the same servers, which is a really powerful thing in and of itself. But they also are optimized for the layers that they operate on. Network load balancers are optimized to be crazy good throughput and low latency for TCP connections. Application load balancers, while slower than network load balancers, have a ton more features. SSL termination, content-based routing with domain or with host or URL, all kinds of really cool things. Sticky sessions, all great things. So not only those great features, but they're cheaper. So that was a good little primer. This kind of stuff will come up and be more important as we talk about our other options. Not other options, are the changes that we're making with our DevOps and our infrastructure stuff. So hope that helps a little bit. Thanks, guys. Bye.